Welcome, Knights, to yet another lesson in algebra. Today we are talking about relationships between quantities. We have all kinds of new key points and all kinds of new vocabulary we're going to be talking about today. So, because there are so many new things, and this video is not going to be quite as exciting as the other ones, I am going to give a joke before every key point. And there are 4 key points, so there will be 4 jokes. That's right, you heard me, 4 jokes in total. I'm going to save the best one for last, so stick with me. Watch the video, listen and learn, and the payoff, not only will you be doing better in class, but you'll also hear some pretty hysterical jokes along the way. All right, let's get started here. Where it says, engage, Jocelyn creates kites and ties 4 bows to the tail of every kite. Number 1, describe how many bows Jocelyn will need to make 4 total kites. How many bows would she need for 5 total kites? So I'm going to start this thing out by kind of taking a cue from what's on my paper and drawing a picture just to help illustrate this. If you really feel like you can't possibly fit it in this space, then that's okay. But I'm going to go ahead and try it. So draw myself. I need a total of 4 kites. So kite number 1, and each of them needs 4 bows. 1, 2, 3, 4. I need a couple more kites. There's my second kite, also with 4 bows. My third kite, also with 4 bows. And my 4th one. So for 4 kites, I would need, this is 4, 8, 12, 16. 16 bows. Forgive me. Sorry, I'm having to cough so much. So, next one. 5 total kites. Well, I just need 1 more. These are beautiful works of art. 5 kites, 4 more bows. So 5 kites equals 20 bows. And if I wanted, I could go back and make them real fancy. Whatever you want to do with your time, make them look nice. So, the next part. List the number of bows she would need for 1, 2, 3, 4, 5 kites. 1 kite equals 4. 2 equals 8. 3 equals 12. 4 equals 16. And the last one, 5 equals 20. All right, you see this here. It's key point number 1. Since we hit a key point, I'm going to give you one of the jokes. All right, you ready for this? How do you make the number 7 even? Do you give up? No? To make 7 even, all you do is take out the S. Duh. All right, key point number 1. A sequence is a pattern that lists numbers, letters, or objects in an order. So, for example, the sequence for the number of bows Jocelyn would need would be, let's go back. The number of bows, 4, 8, 12, 16, 20. The sequence would be 4. Since this is a list, I put a comma. Next one, 8, comma, 12, comma, 16, comma, 20. So that would be my sequence for the number of bows that she needs. There are 4 CFUs here. I'm not going to go over all of them, but I do want you to attempt all of them, and I'm going to go over the first 2, and the other 2 we'll check in class. So at this point, go ahead and pause the video, take a second, do all 4 of these CFUs, and then whenever you're ready to check the first 2, unpause the video. All right, let's check this. Write a sequence that shows the number of eyes that 1, 2, 3, 4, and 5 people would have we're going to assume that all of these people have 2 eyes. So that means for 1, it would be 2 eyes, comma. Then for 2 people, it would be 4. Then it would be 6, 8, and 10. So our sequence would be 2, 4, 6, 8, 10. For the next one, write a sequence that shows the number of fingers that 1, 2, 3, 4, 5 people would have. Again, assuming all of these people have 10 fingers, they would go 10, 20, 30, 40, and 50. Wonderful. All right, looks like we got another key point coming up here, which means it's time for another joke. All right, you ready for this one? So, what do you call 2 friends who help teach each other math? You call them algebros. There you go. All right, key point number 2. A single item and a sequence is called a term. Okay, so when we have a sequence, a single item is called a term. Ooh, I kind of scraped the number out. A term. A single item and a sequence is called a what? A term. So example, we have 4, 8, 12, 16, 20, 24. We have a whole bunch of numbers here. What is the first term of the sequence? So the first term. Well, what's the first number in the list? 4. What is the third term? Well, 4, 8, 12. What is the sixth term? Well, 4, 8, 12, 16, 20, 24. Means that one would be 24. And then it says, what would be the 10th term? Since I don't actually have the 10th term, I can just keep going. It looks like each time it's going up by 4, so 24, 28, 32, 36, 40. So my 10th term would be 40. There is a check for understanding here. I want you to go ahead and pause the video, and whenever you're ready for you to check those 4 problems, unpause the video, and we will go over them. All right, let's do this. What is the first term of the sequence? Well, in the list, the first number is 3. What is the third term of the sequence? 3, 6, 9. So this one would be 9. What is the sixth term of the sequence? So I count. 1, 2, 3, 4, 5, 6 is 18. What would be the 10th term? Well, it's not here, so I keep counting. 21, 24, 27, 30. So the 10th term would be 30. Great. All right, moving on. We are to key point number 3, which means that's time for yet another joke. All right, you ready for this? What did 0 say to 8? He said, nice belt. All right, key point number 3. A term can also refer to a part of an algebraic expression. So this word term, it can mean part of a sequence, but it can also be part of an algebraic expression. So the examples here, looking at the algebraic expressions below, how many terms do you think each expression has? So we have 4 plus x minus j. When it says parts, that means that there are 3 individual pieces here. And those 3 pieces, the first one is 4. The second one is x. That's too thick. Make you thinner. All right. X. And then the last one is minus j. So how many terms are there? A total of 3. What is the first of them? The first one is 4. We're going to do one more together, and then I want you to pause, and you'll do the last 4 without me. So, next one, y plus 8 minus m. So, for this one, it looks like, again, we have 1, 2, 3 terms. So, in total, 3 terms. Now, this question is asking, what is the third term? For this one, notice what is actually in front of the m. This isn't just plus m, this is minus m. When it's a negative number like this, the third term is actually not just m, but negative m. It's negative because it's minus m. If it were plus m, I would put plus, but since it's minus m, I put negative m. All right, at this point, there are 4 more problems here. I want you to pause the video, try these 4 without me, and then whenever you come back, we will check over them. All right, next one, 4b plus 8 minus 3h. We have 1, 2, 3 terms again. So for this one, 3 terms. What is the third term? Well, that's the third one. Notice this isn't just 3h. This is minus 3h because there's a minus sign. All right? So since it's minus 3h, it's negative 3h. On the next one, how many terms do we have? We have 18. We have 5b. And we have plus a. So again, that's 3 terms. Oh no, not what I wanted. 3 terms. What is the second term? So the second one, the one in the middle, would be 5b. Now I could put plus 5b if I want, but if there's no negative, then we just assume that it's already positive. So this is just kind of optional. So you could also write or just 5b. All right, next to last one. 1/2 n, 2w, minus 33, plus 2x. In total, that makes 4 terms. What is the third one? The third one is negative 33. Good, it's the one that's in third position. And the last one, 9j, plus 3m, minus 8k, plus 3/4 z. So, again, there's 4 terms. What is the fourth one? So this one's 3/4 z. And again, I can put the plus sign or I can leave it. For this one, I'm just going to leave it off. All right, moving on. Last key point. Let me fix this. That needs to be on the next page. All right, you know what this means. It's time for the last one. I saved the best one for last. All right, so 2 1/2s walk into Home Depot and ask somebody who works there, hey, where are the shovels? The Home Depot employee looks at them and says, what do you guys need shovels for? The 2 1/2s laugh and say, oh, later on, we're going to go make a hole. All right. Key point number 4. When a variable is multiplied by a number, the number it is multiplied by is called a coefficient. So this is a crazy looking word, coefficient. This is pronounced fish unt. Coefficient. So basically, if you're multiplying a variable by a number, that number is a coefficient. Here we have 3 times n. Man, this is real sloppy. Let me write this better. 3 times n. Since 3 is what it's being multiplied by, this is the coefficient. The coefficient is 3. The variable is n. So what do we call the number that is multiplied by a variable? That is called the coefficient. Sometimes you have a number that is not being multiplied by a variable at all, and that's just called a constant. So 35 is a constant because beside it, there's nothing there. There's no variable, it's just 35. We call it constant because it means that it's never changing, right? So coefficients would be like this, that's being multiplied by a variable, and constants mean something like 6, or 10, or 4,132, right? There's no variable, so those are all constants. So, for instance, if a If a variable does not have a number in front of it, we say that the coefficient is automatically 1. And why do we say that? Well, because think, if you have something like x, x is also the same thing as 1 times x, because anything times 1 is itself. So our example, 18, 5b, and a, we want to ask, is this number a constant or is it a coefficient? Whenever I look here, is there a variable? No, 18 is by itself, so that means that it is a constant. I'm going to abbreviate because it's kind of hard to fit in the box. 18 is a constant. For the next one, 5b, do I see a variable attached to this? Yes, b is a variable, so that means that this is not a constant, it has a coefficient. The coefficient is 5. And for the last part here, the letter A, is this a constant or does it have a coefficient? Well, it's a variable, so that means it does have a coefficient, but since there's no number there, we automatically say that it's the number 1. All right, there are 3 questions here for CFU. I want you to pause the video, and whenever you're done and ready to check those 3, resume it. All right, here we go. Next one, 4 plus x plus 3j. 4, there is no variable, so we call this a constant. For x, there is a variable, but there is no number, so we call this coefficient 1. And for 3j, there is in fact a variable there, so this is a coefficient, and the coefficient is the number 3, because it's what it's multiplied by. For the next one, 4b, there is a variable, so the coefficient, the number it's being multiplied by, is 4. With this one, 8, there is no variable, so this is just a constant. And for 8h, there's a variable, so this has a coefficient, or a number it's multiplied by, which is 8. All right, for this one, 8, this is one that we already did before. We know that this should be a constant. 2x, this has a coefficient of 2, because that's what x is multiplied by. And for 3u, this has a coefficient of 3, because that's what u is multiplied by. All right, that does it for this lesson. We will regroup tomorrow during class and do a little bit more review and talking about algebra. I hope you guys have a good evening, and we will see y'all tomorrow.